Hello Titans, this is Mr. Simpson, and hopefully your quiz over 2.1 through 2.4 went well today, and we're ready to just take inequalities to another level. So the first thing we're going to do today is be solving compound inequalities. So first of all, what is a compound inequality? Well, a compound inequality is an inequality formed using two inequalities joining them with the word and or the word or. So we're going to take a look at some compound inequalities and just show you how this all works. So here it says write each sentence as an inequality. Graph each inequality. So it says a number x is greater than a negative 8 and less than or equal to 4. So if we first do the first part of that right here, a number x is greater than a negative 8 and less than, so again the number x is less than or equal to the number 4. Now that's the compound inequality using the word and. And when we think about the word and means we must satisfy both inequalities. And if you think about it, well, numbers that are greater than a negative 8 and the numbers that are less than or equal to 4, well, it seems like x should lie between a negative 8 and 4. And if you look at it, the big mouth here is open towards the x. So when I write it like this, the big mouth is going to open towards the x. And here, the big mouth is open towards the 4, so we have it like this. And this is read then the same way. X, we read it this way, x is greater than a negative 8 and x is less than or equal to 4. And only ands, compound inequalities that contain the word and, can be written as one sentence without having to use the word and. Now, we're going to erase this one, and I'll show you the example for number 2. Well, first of all, let's graph this. So if we have a number line, we'd have negative 8. I'm going to put the 0 in, and this would be 4. And so we put an open circle at negative 8. We put a closed circle at 4. And now x is between. So these are the answers that satisfy that compound inequality. Alright? That's how we'd solve and graph that compound inequality. Now, I'm going to go ahead and erase this one. Again, if you need to go back, then just rewind it and go back. So now for B, it says a number y is at most, remember at most means less than or equal to 0, or the number y is at least, which is greater than or equal to 2. And if we think about this, the y has to be less than or equal to 0 or greater than or equal to 2. Well, it's a good thing it's the word or, because there are no numbers that can be less than or equal to 0 and greater than or equal to 2. So this can only satisfy one inequality at a time. So when I graph this, I have 0, 1, 2, 3. Go ahead and put the negative 1 there. I have less than or equal to 0. And we have greater than or equal to 2. And so graphically it really shows that, well, there's no way that there's any number that can satisfy both of the inequalities. In fact, there's a few numbers in this part that don't satisfy either of the inequalities. But this is a compound inequality using the word or. Now you try. So pause the video for a moment and then I'll reveal the answer. Alright, a number D is more than 0 and the number D is less than 10. So if we rewrite it, D must be between 0 and 10. It's less than 10, but it's greater than 0. So notice how the big mouth is open towards the D here. And if we were to graph this, we just go from 0 to 10, open on both, and shade it in between. And for number 2, a number A is fewer than a negative 6, or a number A is no less than, would be greater than or equal to, a negative 3. And again, we can't rewrite this. This is how it has to be written with the word or. But if I graph this, I have negative 6, negative 5, negative 4, negative 3. It would be closed at negative 3 and shaded to the right because it's greater than or equal to, and open at negative 6 and then shaded to the left. And again, notice how when it's an OR, the two graphs are disconnected. We actually call the OR a disjunction. Now we want to solve. Well, these are both AND inequalities. They don't have to contain the word AND, but they can. Now when they're written like this and there's just one variable on the inside, I'm going to do these two different ways. The first one, I'm going to break it up into its two inequalities with the word AND between them. So I'd have negative 4 is less than x minus 2 and x minus 2 is less than 3. So now I solve this first one. So I'm going to add 2. I have negative 2 is less than x, which could be written as x is greater than a negative 2. Here I would add the 2. Now we get x is less than 5. And so we could write it as x is greater than a negative 2 and x is less than 5. But again, because it's a word AND, we like to always try to rewrite it without the word and just show that x lies between these two numbers. So then x is greater than a negative 2. Notice how the big mouth is going to open towards the x, because it does here. And then it's less than 5. And again, the big mouth is open towards the 5. So then this would be our final answer. Now, breaking it up into its two separate inequalities sometimes is a must when you have the word AND. But if we look at letter B, as long as there's only one variable and that variable is on the inside, then there's an easier way to solve these. And I'm going to erase this and show you how to solve B, the simpler method. Alright, so if we have it written this way, negative 3 is less than negative 2x plus 1 is less than or equal to 9. We actually have three expressions. We have this expression, we have this expression, and we have this expression. And we want to get x all by itself in the middle. So we're first going to solve this just like we would if it was a two-step inequality. We'd subtract 1 from all three expressions. So now I have negative 4 is less than a negative 2x is less than or equal to 8. And now to solve, I divide every expression by the negative 2. And again, we must remember, if we're going to divide by a negative 2, we have to reverse the sign. And so now I have it written like this. Now, that really doesn't make sense because the larger number's on the left and the smaller number's on the right. So I would recommend that we rewrite this. So we'd have negative 4 and the 2, the x in the middle. And again, the x is less than that 2, but it's greater than or equal to that negative 4. And now we have our final answer. So a little bit easier because you don't have to solve two different inequalities. If you use the word, you just solve it the way it is. Solving ORs are really 2-for-1 specials. Okay, we have two separate inequalities, so we go ahead and we'd add the 5 here. And we have 3y is less than a negative 3, then divide by 3. and we get y is less than negative 1. Or, now I solve this one, so I add 1 to both sides, and I get 2y is greater than 6. Divide by 2, and I get y is greater than 3. And again, we can't do anything else, but just leave it like that. And again, we should graph these, and you'll be required to graph these. So we have negative 1, 0, 1, 2, and 3. And so we go ahead and open circle and to the left, and open circle and to the right. And there's our graph for the compound inequality containing the word or. Alright, now here you could try these. And I'll just quickly I just want you to do number 3 and number 5, and I'll show you those answers, and then we're going to stop the video. So, first one here, I just subtract 4 from every piece. And I get 1 is less than or equal to m is less than 6. And if you were to graph that, it'd go from 1 to 6. Oops. And so it'd be open at 6, closed at 1, and solid in between. And then for number 5, we'd subtract the 3 here, so we'd have 4c is less than or equal to a negative 8. Divide by the 4, and c is less than or equal to a negative 2. Or here we'd add the 8 to both sides, and we get c is greater than 7. And again, if we would graph these real quick, it'd have negative 2 here, 7 here, open and to the right, and this would be closed and to the left. And again, we're getting on to almost 12 minutes in this video, so we're going to stop it right now. We do have an application problem that we probably should go over, but we'll do that in class tomorrow. So again, this is section 2.5, working with compound inequalities.